let's try to solve this problem here. A pipe that is open at both ends has fundamental frequency of 180 Hz. If the speed of the wave is 330 meter per second, calculate the length of the pipe and the frequency of the air column. Okay, let's sketch the situation first. You have a pipe that is open at both ends, so let's sketch it. Okay, then the fundamental frequency is 180 Hz. Fundamental frequency means by it's the first harmonic, and is equals to 1. So you can say that F1 is equals to 180 Hz. Okay, then they also let you know that the speed of the wave is 330 meter per second. Okay, so first question asks for the length of the pipe. Let's try to understand everything clearly. Okay. We know information regarding fundamental frequency, so let's try to sketch fundamental frequency waveform first. Okay, so this is our open pipe. The length is unknown, so let's try it as L. We know that we are talking about fundamental frequency, so both N are antinodes because the particles are free to move here, but A and A cannot sit together. You have to put in a node in between. Okay, so right now you know that over here, distance between two antinodes, that will be lambda over 2. Okay, that is the most fundamental standing wave that you can create. Okay, let me finish things up, label up all the diagram. Okay, so distance between node and node is lambda over 2. So distance between antinode and antinode should be lambda over 2 as well. I'm talking about antinode that are side by side or successive antinode. Okay, successive antinode, the distance between them will be lambda over 2. So from here you can find a relationship between the length of the pipe and the wavelength. The length of the pipe will equals to lambda 1 over 2. Okay, knowing this, we can continue to solve the question because we know that V is equals to F lambda. So this is the first harmonic, so F1 lambda 1. We know that the sound, the wave here has a speed of 330 meter per second and it's now in frequency of 180. So from here you are able to find your lambda 1, but we are not asking for lambda 1. We are asking for the length of the pipe. So what we can do a bit of simultaneous here. Not simultaneous, we can do a bit of substitution. We know that lambda 1 can be replaced by 2 times the length of the pipe. So you can put in 2 times the length of the pipe inside here. Then from here you can find the length of the pipe. The length of the pipe will be 0.917 meter. Okay, a fairly straightforward question. Again, you see the same two sets of equation. V is equals to F lambda and also the relationship between the length of the pipe and the wavelength. Always to do these two things, then technically you can get most of the things that you need. Okay, next, the frequency of the air column at the 5th overtone. Again, see the word overtone, you have to be a bit more careful. Harmonic is easy. What number? That number is N. But if it's overtone, you have to be very clear. What kind of pipe do you have? You have a pipe that is open at both ends, that's why this is open pipe. For open pipe, there's no need to worry about even or odd harmonics. You can just write down all the harmonics because they are all available. F1, F2, F3, F4, F5, F6. Okay, we know that every time we leap once, that's one overtone. Second overtone. Third overtone. Fourth overtone. Fifth overtone. So this is our fifth overtone and N is equal to 6 over here. Okay, so now they're asking for F6. We know that F6 is just let's write the general equation. Because we know harmonics, they are just multiples only. So Fn is equals to NF1. So the sixth harmonic or the fifth overtone is just 6 times F1. So 6 multiplied by F1 is 180 Hertz. So you get your F6 to be 1080 Hertz. Okay, fairly straightforward question to determine the higher harmonics, what's their frequency. Always remember, second harmonic, twice. Third harmonic, thrice. Fourth harmonic, quadruple. Okay, it goes by multiples. So if you're able to ascertain the first harmonic, the other harmonics, their frequency are easily attainable. Okay, that's it for this question. Thank you very much.